All right, I decided to switch songs. We've got In Your Eyes by Incognito. Now we're going to be using a graph to write the equation. This is very similar to the last example we just did, except I don't have to use the slope formula because I've got a graph. I can just count. What is my slope? Rise over run. First of all, is the slope positive or negative? Take a look at the line, look at what it is doing, and determine if our slope is positive or negative. Our line is falling, so our slope is negative. Rise over run. We have 1, 2, 3, 4, 5. A run of 3, so our slope is negative 5/3. And for our point slope formula, we can use either point that we want to. They both have a negative value, but this one is negative 1, 1, which are really easy numbers. So I'm going to go ahead and go with that. And we substitute it into our point slope equation. Slope is negative 5/3. Now our x sub 1 is the opposite of what we think. It's in the asylum, it doesn't act normal. Our x coordinate is negative, in the asylum it becomes positive. Our y coordinate is outside the asylum, so it's normal, so it's still positive. We're going to distribute that negative 5/3 to simplify this into slope-intercept form. I'm going to convert my plus 1 to have a common denominator, so that becomes 3/3. So we have minus 2/3 for our y-intercept. And since we have the graph, we can check to see if our equation makes sense. My y-intercept, I got negative 2/3. That looks like it might be about negative 2/3. So I'm pretty confident in my equation. Last example, applications, of course. So we're going to use our table to determine if the temperature is a function of time. In this case, it would have to be a constant rate of change. So we looked at that in our last video, I think our last section actually. Checking change in y. Seems to be a constant plus 3. And our change in x, now look at this as time. So this is not a change of negative 10. From 12 a.m. to 2 a.m. is a change of 2 hours. And so on. All of my changes are 2 hours. So we do have a constant rate of change. Now remember, because of the way it's set up in the table, x, y, our rate of change is 3 halves. And what I'm actually going to do for the purpose of our equation to make this work, I'm going to call this time equals 0 as opposed to 12 a.m. So the initial start of the day at time equals 0, and then we're going to add 2 hours as time goes on. Otherwise, the 12 would not work with our equation. And I'm just going to go ahead and use that. I've got my intercept at time equals 0, my y-intercept is 50. So I do not have to use point slope form. I can just substitute it right away into our slope-intercept form. And the last piece is interpreting the slope and the y-intercept in the context of the information that we were given. So think about, how did we figure out our slope? Change in y, or temperature, over change in x, or time. So our slope is change in temperature per hour, because we simplified it. Yes, our hours changed by 2, but our temperature changed by 3 halves of a degree per hour, or 3 degrees every 2 hours, if you'd rather word it that way. And then our y-intercept, and we talked about this as well when I changed the 12 to a 0, that was our initial temperature. Alright, it's very important that you can interpret your slope and your y-intercept in a context, because that's the application. That's why we work with lines. It's not very important to work with lines without context. You can't apply that to anything. And finally, our U-try. So I will remind you for the last time to please have these done before you come to class, so that you can work with your peers to determine if your answers are consistent and how to make your answers consistent or come to a consensus if they are not.